So I've got a situation here where we're going to be flipping a coin and trying to find out how many times we flip it until we get a head. So the chance of getting a head on the first go, that's just the probability of heads. The probability of heads is equal to a half. So you're straight in there on the first go. That one's just a half. But to get a heads on the second go means that we have to get a tails on the first one and then a heads on the second one. So it's a half times a half. So that one there is a quarter. Now after 3 goes, if you get either we get tails, tails and heads, which is a half, a half, a half, which is an eighth, or we get tails, 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 which is another half, 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 which is another eighth. Altogether, that makes a quarter there. The other way of doing that is to say, well, it doesn't matter what happens on that go, we're going to stop anyway, so these probabilities have to add up to 1. You're going to learn about a geometric distribution later on where we don't stop after the third go, we keep going until we actually get the heads. And so actually each one keeps going down and down and down. So there's the probability table as we got that. Now this is, so should we do this? Should we do this properly? The TP row is a half, and what's that, 3/4. So the expected value of t is 1.75. And if we do t squared p here, we get a half and 1, and then that's 9/4. And so the expected value of t squared there is 3.75. And to find out my variance, the variance of t is equal to the expected value of t squared, take away the expected value of t squared, and that gives me 0.6875. And I'll do it on the calculator to check, but there's questions.